This video is about applications of right triangle trigonometry. We're going to look at a word problem here. Now, the important thing is to understand what's going on, make a diagram. So we have a kite flying up in the sky. Here's our kite. And next they talk about the angle of elevation between the kite and the ground. So we have to imagine the string coming from the kite down to the ground. Here's our ground here. Now that angle of elevation is the angle from the horizontal of the ground going up to the kite, in this case up to the string. That's the angle of elevation. And in this case that angle, they tell us, is 56 degrees. Next they ask us about the height of the kite. Well, that's measured straight down to the ground, and now you can see our right triangle. This is the height. And since we're being asked what is the height, that's what we're going to use for x. And now there's one other piece of information which they gave us, which is that the string has a length of 40 feet, so that would be this length here. So there you can see our overall picture of what's going on, and hopefully you can see a right triangle in there. And we're going to go ahead and distill that down to a straightforward right triangle. Here it is. And now we want to go ahead and solve. We're trying to solve for x. And I see that x is the side opposite the 56 degrees. And I also see that we're given the hypotenuse. So I'm getting ready to set up a trig function, and I'm thinking about opposite and hypotenuse, and that gives me the sine function. So I'm going to say the sine of my angle, which is 56, is equal to opposite over hypotenuse, so that would be x over 40. And that's the equation I need to solve in order to find x. To isolate the x and clear the fractions, I'm multiplying both sides by 40. This gives me 40 times the sine of 56 is equal to x. And you just need to work that out on the calculator. We are going to round to the nearest tenth. You should come down to x equals 33.2. But beware, you need to write your answer with some words and some units. So let's see what a good answer would be. Check what is the question here. And once you see what the question is, you should be able to go ahead and get the answer together. The height of the kite is 33.2 feet. And that's to the nearest tenth of a foot. Here's another word problem. Again, the beginning is the whole setup here. Here's my ladder. And it's leaning against a wall. They tell us how far the bottom is from the wall. So the bottom of the ladder is 10 feet from the wall. So this would be 10. What else did they give us here? They said the ladder is 32 feet, so this is 32. So we know the length of the ladder. We know how far away from the wall it is. Of course, this is a little right angle here. And what are they asking us for here? They're asking for the angle between the ladder and the ground. Do you see where that is? This is the angle that we're looking for. So this is my x. We're looking for this angle right here. Again, I'm going to distill that to a straightforward right triangle, and then we'll see how we're going to solve it. There's the x that we're looking for. Well, let's look at what we have here. We have the length of the side adjacent to the angle in question. We have the hypotenuse, so I'm thinking about the trig function that relates the adjacent and the hypotenuse, and that is cosine. So the cosine of x, because I don't know what that angle is, but the cosine is this ratio 10 divided by 32. Now this is a case where we're looking for the angle. So I have x is equal to the inverse cosine of 10 over 32. And you need to work that out, rounding to the nearest tenth, and you should be getting 71.8. Now that's not the answer, because this is a word problem and you want to answer with a sentence including the units. So in this case we have the angle between the ladder and the ground is 71.8 degrees.